AP Calculus AB, Unit 9, Day 3 office hours. These are the answers. I'm going to just show them very quickly, so pause the video if you need to check them. They should also be already attached to this video and for you to check them that way. And last one's using a graphing calculator, like I showed in class. Did a couple examples in class like that. So there's plenty of setup and work to show, even though you're using a calculator to get full credit. On the AP test, okay, the first two are just kind of review problems. It says to use geometry to do this absolute value. So that means drawing a picture of the graph, going 0 to 6. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So I'm just going to graph line first, -4, up 2 over 1, 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 up 2 over 1. And then the absolute value just folds the negative part up. It's going to get positive. So this is the actual absolute value graph. So we're going 0 to 6. So essentially it's two triangles, right? It's a small triangle plus a big triangle. So it's 1/2 base times height and 1/2 base times height. And the first one has a base of 2 and a height of 4. The second one has a base of 4 and a height of, got to make sure you get this right, it's going up 2 over 1. So that'd be at 8. So we get 4 plus 16. 4 is the area of the small triangle, 16 is the area of the big triangle, and together we get 20. So that's one option, as long as the graphs are very linear in nature, triangles, rectangles, trapezoids, things like that. But most functions aren't like that. So we're going to do this one and solve it the more common way. So what you usually want to do is figure out where the zeros are by setting the inside equal to 0 and factoring it and doing a line check. -2, 0, and 2. Test a value, watch out for bounces. Test x equals 3, positive, negative, positive, negative. So this shows you where to break it up. It also shows you what parts are negative that you're going to fix. So if you're going -1, you can go -1 to 0, drop the absolute values. It's positive, don't need to do anything extra. Then we're going to go 0 to 2 and drop the absolute values. But this is going to come out negative, so we're going to fix it by making it positive by putting a negative in front. Then 2 to 4, drop the absolute values. That should be good. Okay. So now integrating them, x to the 4th over 4 minus 4x squared over 2. That's going to be 2. Now they're all going to have the same antiderivative. So take advantage of that. Okay, and then we're going to plug top limits in first. So that's going to be 0 minus 0 minus, you plug -1, you get 1/4 minus 2 So it's that one. Be careful. There's a lot of subtraction, a lot of distribution that has to go on here. Plug 2 in, you're going to get 16 over 4 is 4, minus 2 times 4 is 8. Plug 0 in, you get 0 minus 0. You plug 4 in here, we get 4 times 4 is 16, 64. It's going to be 64 minus 32. And then we plug 2 in. It's going to be 16 over 4 is 4 minus 8. So you got to be super careful here. Now, each of these is the area of a chunk of the curve, and they should each end up turning out positive in the end. So this is negative 1 3/4. There's another negative, so it's positive 7/4. This is negative 4, but then there's an extra negative that fixes it, makes it positive 4. This is 16 minus, that's negative 4, so that's going to be 20. So we're going to get 24, 25 3/4, or 103. Okay, I think I've made a mistake. Let me double check my work. Just trying to make sure. Did I make a mistake? Okay. 64 minus 32 is 32. So this should be 36. So this is going to be 41 3/4. So then that'd be 164, 167 fourths. So that's how we have to deal with absolute values. Okay, fundamental theorem of calculus. These are pleasantly fast. We said that the derivatives undo the integrals, but then you got to plug limits in. But then chain rule says you still got to take the derivative of the limit. This derivative undid this integral, but then you still haven't done the derivative of what's inside. So you write sine x cubed and multiply by the derivative of what you plugged in. Minus, it's always minus, sine of x, derivative of what you plugged in, just to be sure that you don't forget. This is 1. Final answer, 3x squared, sine x cubed, minus sine x. Okay. We did number 4 in class together. Plug 6 in, derivative 6 is 0, so that whole term just drops out. Plug x in, derivative x is 1, but there's a negative here because we always subtract the second term. This one is going to undo. We're going to plug that in, so it's going to be, now I usually leave some room here, could put the chain rule in front just right away. E sine x, derivative of sine x is cosine x. Got to put that out in front. Minus e to the x squared. We're only doing the derivative of what we plugged in. X squared is 2x. Final answer, cosine x, e to the sine x, plus minus 2x e to the x squared. All right, next one. Those undo each other. So we just get secant squared, and we plug x cubed in, and then secant squared, and we plug 3 in. You can multiply by the derivative of what you plugged in, so it's going to be 3x squared. Derivative of 3 is 0, so that whole term goes away, and our final answer is 3x squared secant squared x cubed. So those are fast. I mean, you should love those. I don't know if we've had problems that fast in a long time. So we got some more on the back here. Plug limits in, so it's going to be sine of 5 squared, and it might just be good to go ahead and always just put it in parentheses first, otherwise you might make a mistake. Sine of parentheses x cubed squared, derivative of 5 is 0, that term goes away. Derivative of x cubed is 3x squared. See, the thing I think people might be tempted to do is if they write x cubed squared as x is 6 right away, they're going to put 6x to the 5th in front, and that is not correct. So I'm usually very patient and then simplify afterwards to make sure I don't make mistakes. Here, we're going to get cosine of e to the x cubed minus cosine of 4 cubed. Derivative of e to the x is e to the x. Derivative of 4 is 0. That term goes away. E to the x, cosine e to the 3x. Simplify your answers, rules of exponents. Okay, this one here, those are going to undo each other. We're going to plug the top in first. So we're going to get sine of 4x squared minus sine of 4x cubed. Then we've got to multiply by the derivative of what's inside. Chain rule, 2x. Just what we plugged in. Everything else has been taken care of. 3x squared. So this is going to be 2x sine 4x squared minus 3x squared sine 4x cubed. Okay, one more of these. So those are going to undo each other. Now, every place you see it, you're going to plug this in. So this is going to be tangent x e to the tangent x. And then this is going to be e to the 3x e to the 3x. When we multiply by what's inside, we only do it once. It's only what got plugged in inside, even though it's shown up multiple times. Derivative tangent is secant squared. The derivative of e to the 3x is 3e to the 3x, right? So we just do it, even though we plugged in multiple places, we just do the derivative of what's inside once. So, secant squared x, tangent x, e to the tangent x, minus, we could do a little bit of cleaning this up. Rules of exponents say you could add all these up. So it'd be e to the 6x plus e to the 3x, all inside that exponent. Make sure that's clear. That's it. Those are fast. Now here's a couple using fundamental theorem calculus part 1 in a new way and using our calculators. 1, just because we can, if they say we can, and 2, because we probably couldn't do it without it a lot of times. So if I give you f of 2 is 7 and I want f of 10 and I have the derivative, then we know that if we integrate the derivative of a function, we get the original function. And if it's a definite integral, we plug in the limit. So if we have 2 and we want 10, let's put those as limits, smallest to biggest. And then we plug those in, top first, bottom second. So this is fundamental theorem calculus part 1. Basic idea, integrated derivative, you get the original function. Plug limits in, top first, bottom second. Basic idea we've been using for a long time now. Now, this is what we're trying to get. So I'm going to add this to the other side. And another way to interpret this that we were talking about in the lesson is that you are now what you were before plus the accumulation of all the changes. Derivative is change, right? So f of 2 is 7. And they're going to integrate f prime, which is x squared natural log of x, which you have no shot at integrating by hand this year. And I could just do this all in one calculation on my calculator. So I'm going to do it. I'm going to say 7 plus math 9 x squared natural log of x, close the parentheses, comma x, comma 2, comma 10. Done. That's why you want to use your calculator, even if you could do it by hand, because that's so fast. 662.457 is what I would do, truncate. If you rounded, it would happen to give you a different answer this time, which would be okay. But I personally just go with truncated. Okay, one more of these. You have f of 8, you want f of 1, you have the derivative, perfect. If we know, and this is what I'd always write down, if we integrate the derivative, we get the original function. We want 1, we know 8, whatever's smaller, put in the bottom, whatever's bigger, put in the top, and then I plug those in, top first minus bottom second. All right, we're looking for this. So that means we're going to have to add it and then subtract this. So doing a little algebra in my head, f of 1 equals f of 8 minus 1 to 8 of f prime of x dx. So even though we use our calculator, we're going to show a little bit of work showing that we understand how this works. We've got to show our setups. We've got to show what we're going to plug into our calculator. You don't got to tell me what buttons, but you got to tell me the calculus that you're going to accomplish on your calculator. So we can do this all at once. 2 minus 2 minus math 9 x sine x. You better be in radio mode because we got a trig here. Comma x, comma 1, comma 8. Done. F of 1 is 0.147, 3 decimal place, truncated. Or if you really want to round it, that's what you get. That's it. This was kind of a quicker assignment, I would say.